Section 10.6. This is alternating series. And they go through a whole page in here talking about how we know the harmonic series diverges. And remember, that's the summation of k equals 1 to infinity of 1 over k. But the alternating harmonic, which the only difference is going to be the alternating part, it converges. And that summation, k equals 1 to infinity, put the alternating part in there with a plus 1 so that the first term starts out positive, and that's all over k. That series is 1, negative 1/2, 1/3, negative 1/4, plus 1/5, and so on. So it alternates. And they go through and they show you how when you plot the partial sums, they are approaching a number, and they actually have a picture in there for you to see. So the alternating harmonic does converge. So with that, then we go down to the theorem for alternating series. And it says, if you have some kind of a summation of something that's alternating, it will converge, converges provided, and we've got two things. The terms of the series are non-increasing in magnitude. Terms are non-increasing, meaning they are either decreasing or staying the same. And secondly, if you take the limit as k goes to infinity of the a sub k, forget about the alternating part, it's going to 0. Which should make sense. If the terms without the plus and minus involved are going towards 0, then when they're alternating, they're approaching the same number from opposite sides. And so let's look at example 1, and it has 3 parts to it. Determine whether the following series converge or diverge. Part A is k equals 1 to infinity, negative 1 to the k plus 1, all over k squared. So, as I put terms in, do they decrease in magnitude as k gets larger? Yes, they do. So that works. So then I'm going to say decreasing, and then I'm going to take the limit as k goes to infinity of just the 1 over k squared, which goes to 0. It meets the requirement, so therefore the series converges. And this is by the alternating series test. Part B. Oh, now this time they didn't give us the summation. Okay, so if I look at these, what is generating this? The kth term would have to be, well, this is the first term, the second term, the third term. So the bottoms are whatever term number you're on, and the tops are one higher. So that would be the summation symbol that you're going to use, which I could turn into 1 plus 1 over k if I split it up. So if I look at this, yes, the terms are decreasing as we go, so decreasing. However, the limit as k goes to infinity, and I could write it either way. If I write it like this, I can see the exponents, the degree is the same, so the answer is 1, but the rule says it has to approach 0. So, and remember, this test only tells you if something converges. It doesn't tell you about diverging. So if I go to the divergence test and you take the limit, the divergence test said if you take the limit and you get something other than 1, the series diverges. So in this case, it diverges by the divergence test. Okay, part C. K equals 2 to infinity. Okay, there must be a reason why they're saying 2. Oh, because we have a natural log. So, do they decrease? Well, let's just look at f of x equals the ln of x, x over x. If I graphed it, we could see that they decrease, but if I took its derivative, that would also show me that they decrease. I'd have to use the quotient rule on it, and I'd have the bottom times the derivative of the top minus the top times the derivative of the bottom, all of the bottom squared. I would end up with 1 minus the natural log of x over x squared. If you look at this and you stick in a number, any number you want to, the denominator is going to be positive. The numerator is going to be what? It's going to be negative. If I pick, I got to figure out which one. I've got to pick a number higher than something. Natural log of 2, and you have to use your calculator and figure these up. Okay, so if you start with 2, and then you plug in 3, yeah, I could say definitely after 3, because then it's going to come out negative. The derivative will turn out to be less than 0 when x is greater than or equal to 3. Okay, and the reason I know that is because the natural log of e is 1. If I put an e in there, I would get 0 up there. So after e, it's okay. Well, what's the first integer after e? It's got to be 3. So I can say that it is decreasing. So decreasing for k greater than or equal to 3. All right, now since I'm going to infinity, that's probably realistic enough. Now I'm going to take the limit as k goes to infinity of the ln of k over k. And remember, the bottom, the ln grows rather slowly. K is going to grow faster than ln. So this is going to go to 0. And so, yes, I can say the conditions of the alternating series are met and the series converges. And by alternating series test.